We're now going to move on to chemistry. Remember, the first 2 units of chemistry are in this programme. The other 3 are in the next Science Bite-Size programme, along with a number of physics units. When you're getting to grips with chemistry, it's a good idea to try and imagine what the particles in a substance are actually doing. This next section about classifying material will give you lots of help with that. Classifying material is divided into 4 sections. We'll start with states of matter. Matter is all around us. It's the word used to describe everything that exists. Every substance is made of a different kind of matter, so you need to be clear that substances can exist in all 3 different states of matter, and these are solid, liquid, and gas. For instance, here water is in all 3 states. My cold drink has ice and water, solid and liquid states. My tea is also in the liquid state, but the steam coming from the kettle is a mixture of tiny water droplets and water vapour, the gas. The 3 different states we can see water in are dependent on the temperature, and that's what we're going to look at next. When a substance changes state, we say a physical change takes place. If a solid substance is heated to produce a liquid, the liquid can then be cooled and returned to its original solid state. Here we have the solid paraffin wax being heated, and as you can see, it quickly becomes a transparent liquid. Remember that even though a substance looks and behaves differently in its different state, it is still chemically the same substance. Let's look at some other examples.
Another gas in the air is oxygen. And like carbon dioxide, it's invisible. Usually.
Oxygen gas passes through this tube into a copper pipe. The bucket contains liquid nitrogen at minus 196 degrees Celsius. Very cold indeed. After a few minutes of cooling, look at the end of the pipe. Drops of liquid. It's so cold that the oxygen gas passing through the tube becomes a liquid. It condenses. In this tube, there's a solid, bromine. This is liquid bromine. And now, the tube is filling with brown gas. Bromine again. The same stuff, but in totally different forms.
We're not used to seeing oxygen as a liquid. It's always a gas in the temperature range we live in. And we're used to seeing substances in one particular state within this range. Metals, for instance, are usually solid, but look at the one in the next clip.
As the temperature rises, solids become liquids. They melt. Even in here, it's warm enough for one particular metal to be a liquid. Mercury in the thermometer, a liquid metal at room temperature. You might think that metals are solids, but of course, like everything else, metals can be liquids and gases too.
This coin is made out of the metal gallium. It's a solid at room temperature. But gallium metal melts at 30 degrees. My hand is warm enough to melt it.
So the change of state from liquid to solid is called freezing and happens at the freezing point of the liquid. And the change of state when a solid is heated and becomes a liquid is called melting, and this happens at the melting point. In a test paper, you will often be asked questions about the boiling, melting and freezing points of substances. So let's run through a typical experiment. We can add a thermometer to a beaker full of crushed ice. And if we heat it gently, we can take readings every minute and then plot the temperature of the ice against time. You can then plot a graph of the temperature rises over the 15-minute period. These graphs often appear in test papers, so make sure you are familiar with their layout. This is a graph for water. You can see the melting point, MP, where the solid becomes a liquid, and then at a higher temperature, 100 degrees Celsius, the boiling point, BP, where there is another change of state from liquid to gas. If we look at another substance plotted on the graph, we can see that the pattern is similar, but the substance has different melting and boiling points. To explain the properties of solids, liquids and gases, and how they change from one to the other, we can use the particle theory of matter. Now, the particle theory of matter is one of the really key scientific concepts you need to know and understand well. And we're going to go through it step by step. In a solid, the particles are closely packed and held tightly together. They're not completely still, just vibrating very gently. This explains why solids have a rigid structure and a fixed shape and are hard to compress. The particles in a liquid are also closely packed, but they move over each other. Liquids take on the shape of their container, are hard to compress, flow easily, and have a fixed volume. In gases, the particles are not closely packed. They're spaced out and move around very quickly. This means gases also take the shape of their container, but they are easy to compress and flow readily. But unlike liquids, they have the volume of the container. How do you explain the properties of a liquid using the particle model? Sounds like we need to check through those micro marvels again. Stop the tape and have a go at the question yourself. Your answer could include 3 points. The particles move over each other. They have no fixed shape. The particles are still touching, are close together, so a liquid is still hard to compress. And the particles move. They flow over each other.
With solids and liquids and gases, to remember the particles, we once played a game, and I can really well remember that, and the teacher would hold up a card saying gas or liquid, and we'd all have to spread out like those particles.
When we're looking at solids, liquids and gases, we need to know the way they change into each other. The key words are melting, freezing, boiling, condensing. You need to know the vocab.
So the key points to remember about the different states using the particle theory of matter are: in a solid, the particles are close together, have a fixed shape, and gently vibrate. In a liquid, the particles are still close together, touching, but with no fixed shape, and move about slowly. And in a gas, the particles are far apart from each other, have no fixed shape, and move quickly and randomly. If I leave this glass of water here in the studio over several days, the water level will go down. The water has evaporated into the atmosphere. Evaporation. Let's look more closely again at the particle level. At any temperature when water is liquid, there are always some water particles that move fast enough to escape. They move from the surface into the atmosphere, and it's this losing of particles into the air that is evaporation. And the rate of evaporation is faster at a higher temperature. So the warmer it is, the faster the particles move, which means more escape from the surface. The other factors that affect the rate of evaporation from my glass of water are the amount of water vapour already present in the surrounding air and the speed at which the air is moving past the surface of the liquid. Here's another question where you need to use the particle model to explain your answer. What do you think are the best conditions to get clothes on a washing line dry? Why not stop the tape and jot a few notes down? Your answer should have 3 points. The best conditions for this washing to dry would be a sunny day. The sun will increase the temperature and give the water particles more energy to escape. A windy day. The wind will push the water particles away from the washing, leaving room for more to escape. And the third point would be low humidity. There are few water particles in the air already, so there's space for lots more. So sun, wind and low humidity to get the washing dry. The opposite of evaporation is condensation. If I breathe on my sunglasses here, the water vapour in my breath condenses back into tiny water droplets on the glass's surface. Let's take another look. Remember, condensation is the opposite of evaporation. It's when a gas becomes a liquid. Here, water vapour comes into contact with a much colder surface and turns back into tiny water droplets. The particles in the gas have less energy because of the lower temperature, and so move more slowly and eventually gather together to form a liquid. This is how clouds form and condensation appears on windows. This completes the first unit of chemistry on classifying material. Make sure that you really understand the particle model and can use it to describe how solids, liquids and gases can behave. Rewind and play this section again if you need to go over it, and there are more practice questions in the book and on the website. Don't forget to have a break.